Hi, this is Mr. Whalen, and in this video I'd like to explain why the mole is the number it is so we can begin to use the periodic table in our experiments. Because one of the difficulties in the lab is that we can't see atoms or count them one by one, but we can measure masses. And so is there a way to go from masses to number of atoms and vice versa? There is in the mole. So first of all, here's a periodic table. This one's got a lot of information on it, but it's the only one I had on hand. But when you look at the periodic table, any one of these boxes will give you some information about whatever element you're examining. I'm going to focus on carbon for now. So when I look at carbon, I get a few things. Atomic number 6, atomic symbol C, atomic mass 12.011. Now what does that tell me about carbon? Well, first of all, it tells me that if I have one carbon atom, like this one here, it has a mass of 12.011 AMU. That's atomic mass units. And that number comes from the number on the box from the periodic table, 12.011. Pretty straightforward. Now recall that a mole is 6.02 times 10 to the 23rd representative particles. Could be atoms, molecules, or formula units. In this case, I'm talking about atoms. Recall, this is a very, very big number, but I happen to have a sample of it right here. This is 6.02 times 10 to the 23rd carbon atoms. Just so we don't forget. So I would be right in saying that this is 1 mole of carbon. Now, it turns out that 6.02 times 10 to the 23rd carbon atoms, like I have right here, has a mass of 12.011 grams. Now, that should strike you. Why? Well, because the numerical value that you see here, 12.011 grams, is the same numerical value as what's up here, 12.011, which is the same as the numerical value we see on the periodic table, 12.011. So when I see this number on the periodic table, it tells me a few things about samples of this element. First of all, it tells me that one atom has a mass of 12.011 atomic mass units, and it tells me that 1 mole of carbon atoms has a mass of 12.011 grams. It's the same numerical value, just different units. Moles and grams here, atoms and atomic mass units there. And that's the reason why the mole is the number that it is, 6.02 times 10 to the 23rd. If you've been wondering how come it's not 6.01 or 5.02 times 10 to the 23rd, this is the reason why. 6.02 times 10 to the 23rd atoms is what gives you a mass, which is the same numerical value as the mass of a single atom, just in grams rather than atomic mass units. Now this relationship has a special name, and if I put my little fraction symbol in here, you can see how it's written sometimes. 12.011 grams per mole. This is called a molar mass, and sometimes it's just shortened to this. I would read this as the molar mass of carbon is 12.011 grams per mole. And you can find that same molar mass for any element on the periodic table using the same technique. Let me show you what I mean. So if I were to look on the periodic table and find neon over here, and I look closer, I find that neon, which is atomic number 10, has a atomic mass number of 20.18. The first thing that tells me is 1 atom of neon is 20.18 atomic mass units. But it also means that 1 mole of neon is 20.18 grams. Same numerical value, just a slightly different relationship. Atoms to AMU, moles to grams. Let's try another one. When I look on the periodic table and look at chlorine, atomic number 17, atomic mass 35.45, what that means first of all is that 1 atom of chlorine is 35.45 AMU. What that tells me now that we've learned about the mole, that tells me that 1 mole of chlorine atoms would be 35.45 grams. If I have 35.45 grams of chlorine, that is 1 mole of chlorine atoms. Again, same numerical value, different relationship. Atoms to AMU, mole to grams. But this is the number that you see on the periodic table. Both of these numbers come from the periodic table. And one more thing, the same technique holds true for molecules, or formula units for that matter. If I have a molecule of Cl2, remember, a molecule of Cl2, that's just 2 chlorine atoms. So it would be 35.45 times 2. That would be the mass of 1 molecule of Cl2, 70.9 atomic mass units. What that means also is 1 mole of Cl2 would be 70.9 grams. So the mass of 1 molecule in AMU is the same numerical value as the mass of 1 mole of the same molecule, just in grams rather than atomic mass units. So this is the only thing that changes. Molecules to moles, AMU to grams. Atoms to moles, AMUs to grams. Atoms to moles, AMU to grams. So that's how we use the periodic table to find molar masses. And in the next video, we'll talk about how to use this in problems. I hope that was helpful.